Alright, hello, this is my first video. I'm doing problem 6 of chapter 9, and the problem says, a model rocket's engines are rated by the impulse that they deliver when they fire. A particular engine is rated to deliver an impulse of 3.5 kilograms times meters per second. The engine powers a 120-gram rocket, including the mass of the engine. What is the final speed of the rocket once the engine is fired? And it tells us to ignore the change in mass as the engine fires and ignore the weight force during the duration firing of the engine. So what are our knowns? Our knowns are that we know that the impulse on a particle equals the change in the particle's momentum. And we know that by this equation. Sorry, this is really interesting to do. Okay. P, F, let me look at my notes. And so from that equation, we know that the impulse equals the momentum is equal to the change in the particle's momentum. Sorry, and that's when the particle's momentum is equal to P equals mass times velocity. And what's given to us in this equation is, let me pause. Okay, so this is the equations we're using, and what's given to us in the equation is going to be the mass of the rocket, which is given to us to be 120 times 10 to the negative third kilograms. And then our joules, or the impulse, is going to be J equals 3.5 kilograms times meters per second. All right. So from that, we know how much it weighs and the impulse of the rocket. So with that, from equations 1 and 2 that I wrote up, we can write the impulse in terms of the mass and the velocities as follows. And so let me write how that would be. And it's going to be okay. So that's how we're going to do that. And then for the rocket, since it starts from rest, we know that our initial is going to be 0. And then the impulse on it would be, it's going to be, we're not going to have to worry about 0. So we're just going to erase that. And we know that the impulse is actually just going to be the mass times the final velocity. So when we plug in our values for that, so we have our mass is going to be 120 times 10 to the negative third kilograms times meters per second. And then we're going to multiply that by our final velocity, which was given to us at, and then J, our impulse, was given to us. So that's how we're going to find our final velocity. So this was going to be equal to 3.5 kg times meters per second. Sorry, that's starting to get a little messy. But from there, so because our initial velocity was 0, we got rid of that. So now it's just V final times mass is equal to the impulse. The impulse was given to us, and it's right here. And we have our mass. So what we're going to do is we're going to divide our divide this out and put it over here. So 120 times 10 to the negative 3. And when we do that, we're going to get our meters per second because the kilograms from the impulse and from the mass cancel out. And that's going to give us 29.2 meters per second. And I did all the work beforehand. That way in the video, I didn't have to plug it in. But essentially, that's all we had to do. to be able to figure out the final speed. Thank you.